Welcome everyone to today's presentation on the P113 antimicrobial peptide. P113 is a powerful short-chain peptide consisting of just 12 amino acids, derived from a natural component of human saliva known as histatin 5. Over the next few minutes, we will dive into its unique molecular origin, explore its antimicrobial mechanisms, and review the clinical evidence supporting its use in oral health. Whether you are focused on basic research or product development, this roadmap will provide a comprehensive look at how P113 can be leveraged in the next generation of oral care solutions. To understand why P113 is so effective, we first need to look at its structure. It is essentially a functional fragment of histatin 5, specifically designed to maintain high activity in a compact form. The sequence, AKRHHKRKFH, is rich in histidine and lysine, giving it a strong positive charge. This charge is crucial because it allows the peptide to interact selectively with negatively charged microbial surfaces. It's a beautifully simple 12 amino acid chain that serves as the foundation for its potent antimicrobial properties. How does P113 actually fight pathogens? It's a multi-step process. First, it binds to the cell wall components of fungi, like Candida albicans. Once attached, it doesn't just sit there. It can cross the cell membrane through a process called translocation. Finally, it delivers a lethal blow, either by disrupting the membrane, leading to a leakage of essential ions and ATP, or by targeting internal structures. While the exact dominant mechanism can vary depending on the environment, the result is a highly effective clearing of pathogenic fungi. In terms of its activity spectrum, P113 is a versatile performer. It is most famous for its strong inhibitory action against Candida albicans, which is a major cause of oral yeast infections. But its potential doesn't stop there. Research has also shown promising activity against bacteria like Pseudomonas and Staphylococcus, as well as S. mutans, the primary culprit behind dental cavities. However, it's important to remember that in vitro success is just the starting point. Real-world efficacy depends heavily on the specific formulation and the complex environment of the human mouth.
Moving from the lab to the clinic, the human data for P113 is very encouraging. In Phase 1 and Phase 2 trials for oral candidiasis, P113 mouthwashes were not only well tolerated, but showed a clinical cure rate of 37%, which is remarkably comparable to standard treatments like Nistidine. We've also seen early-stage trials where P113 gel significantly reduced signs of gingivitis over a 4-week period. These studies serve as a strong green light for the safety and feasibility of P113 in clinical applications.
So, where can we actually use P113? The application scenarios are broad. For immunocompromised individuals, it could be a vital tool in managing oral candidiasis through specialized sprays or gels. In the consumer market, it offers exciting possibilities for daily use products like mouthwashes or toothpastes aimed at disrupting dental plaque and maintaining a healthy microbial balance. By combining P113 with fluoride or anti-inflammatory agents, we can create comprehensive solutions for those at high risk for caries or periodontal disease. Developing a successful P113 product requires careful consideration of the oral environment. Saliva contains proteases that can degrade peptides, and the presence of various ions can interfere with how the peptide binds to microbes. To overcome this, we look at advanced delivery systems like mucoadhesive gels that increase contact time. It is vital to test these formulations under simulated saliva conditions to ensure that the antimicrobial activity we see in the lab translates into measurable clinical benefits, like a lower plaque index or reduced inflammation. Looking at the commercial landscape, P113's greatest strength is its origin. Being derived from a natural human peptide gives it a fantastic safety and biocompatibility story. However, we must be mindful of the challenges, such as the cost of peptide raw materials and the regulatory pathways required for medicinal claims. A smart strategy is to start with functional daily care products focused on plaque control and oral comfort, while building a rigorous evidence framework if you choose to pursue specific disease treatment indications. To wrap up, P113 is a scientifically grounded 12-amino acid peptide with proven anti-candida activity and significant potential for broader oral health applications. As we move forward, our R&D focus should be on establishing robust biofilm models and optimizing delivery formats like sprays and gels for better retention. By clearly defining our clinical endpoints and navigating the regulatory landscape early, we can successfully transition P113 from a promising molecule to a staple of modern oral care.